Hello viewers, welcome to another video. In this video, we will going to study the continuous time signals and discrete time signals. So first of all, what is continuous time signal? Let me draw a signal. So this is time axis and this is our function which is represented by xt 0. So a continuous time signal is defined as the signal which has an infinite values on the time axis or the x-axis as well as on the y-axis. So if we make a continuous signal, a periodic signal, so what we do, we make a copies of the same signal xt. Similarly on minus x axis. So let's say we have a time period of capital T, this is minus t and 0. So it will continue on the right as well as on the left side. Again, this is xt. Now xt is called a periodic signal if xt is equal to xt plus multiple of capital T. So let's try to understand this equation. This is very important. So capital is the time period of a signal. So if we shift the signal right side or left side on x-axis, the shifted signal is equal to base signal. So this is called periodic signal. Okay, let's take an example of how a signal can be a periodic signal. So let's say we have xt, a periodic signal, which let's draw a base signal with red color and the remaining copies of the signal with the blue color. So time period will again be the same, capital T. Let's draw another at 2t. Similarly, we have a copy of same signal on minus t and minus 2t. So this is our xt. Now check xt is periodic or aperiodic. Xt plus 2t. So what happens when we shift the signal on the right? The base signal will move from 0 to 2t and the whole signal will change its position by 2t. So this minus 2t will come on 0 and the signal will repeat on the left and on the right side. So you can see here that after shifting the signal on the x-axis, the shifted signal and the base signal is exactly the same. So if the shifted signal and the base signal is same, then we can say that this function or this signal is a periodic signal. Similarly, now let's talk about the discrete signal. The discrete signal is represented by x of n. Let's draw a continuous signal first. So if we take the sample here, here, 4, similarly. So at 1, the signal value is here, 2 here, the same values on all the points. Remove all the values between the points and take only these points and draw another signal in which only points are visible at 1. On the y-axis comes the magnitude of the signal, which let's say is here is 1. So these are the spikes you can draw. So xn will always be a spike signal. You can see the spikes in a discrete signal, and these are the sampled values of continuous signal. Now let's try to understand a discrete periodic signal. Discrete and periodic signal. Again, if xn equal to xn plus capital N or xn plus n naught capital N, if xn is equal to this signal, then the signal is discrete and periodic signal. So let's try to understand what is capital N. Capital N is the fundamental period of signal. So let's draw a signal. So here you can see that the signal repeats itself after 3 samples. So this will be over capital N. So after this time period, the whole signal will repeat itself. So how can this signal be a periodic signal? Again, if we shift this signal xn by one time period, and I am going to shift this signal on the right, this base signal will be shifted to 3, 4 and 5. So this signal will be shifted on to 3, 4, 5, and this signal will shift on 0. Again, you see that this shifted signal is equal to the base signal, but with n fundamental period equal to 3 samples. So I hope you understand what is continuous signal and what is the discrete signal, and what are the periodic signal in continuous time and discrete time signals. So for more interesting videos, stay tuned and don't forget to subscribe our channel. Thank you for watching.